In this section, we want to look at evaluating a piecewise function. So first off, what is a piecewise function? A piecewise function is a function that has pieces of it put together. For example, if I was just drawing a graph and I started drawing this kind of squiggle, and then I picked up my pencil, and then I started back again, and I drew some more, and then I stopped, and then I picked up my pencil, and then I drew something else. A piecewise function would look like this because I took pieces of it together. Now, we are going to look at a piecewise function. So a piecewise function means at these spots where my graph stops and starts again, one must be excluded and one must be included. Doesn't matter which one, it's just saying that I can start and stop, but I never overlap, okay? So what would not be an example of a piecewise function is if I started drawing, I picked up my pencil, and then I started drawing on top of the function that I already had. Or if I started drawing, I pick up my pencil, I start drawing, and both of those have closed dots, okay? So that's what a piecewise function is, right? So what we want to do is we want to evaluate those functions. So remember, evaluating just means that I'm going to plug something in. I'm just going to erase these so we have some more room here. When I plug something in a piecewise function, the first question is, well, which piece do I plug it into? Then after I know which piece, then I go plug it in. So before, when we were just evaluating a function, I plug it straight into the one function that I have. In a piecewise function, I first determine which piece to plug it into, and then I plug it in. I'm only going to plug it into the one place that it fits, the one place that the domain checks out. I say domain because if you notice in these examples, they give me if x is this. Remember, the x values describes the domain. Okay, so it's really pretty simple. I'm going to talk through the first one. I think it'll make sense for us. Okay, so if they give me a function, it looks a little bit different. It's got this bracket, and then it's got kind of an expression, and then it's got words. So what this is saying is, if I give you a number that is less than or equal to 1, I want you to use 2x. If I give you a number that's greater than -1, then I want you to use x minus 1. So the question is, well, what number did you give me? Okay, so let's look at our first question. The first question says f of -5. So that means they're telling me that x is -5. So what I need to do is I need to go back over here. Well, if x is less than or equal to 1, so is -5 less than or equal to -1? Well, it sure is. That means that I need to use 2x. So I'm going to come over here. I'm going to use 2x, which means I'm going to plug in. So I'm going to get 2 times -5, which will give me -10. So I didn't do anything with the x minus 1 because -5 was less than or equal to -1. All right, so let's look at our next one. -1. So I'm going to go up here. X is -1. I'm going to plug that in. Is -1 less than or equal to -1? It sure is. So again, I'm going to use 2x. So I'm going to say 2 times -1. So my answer is -2. All right. Now my next one is 3. So I'm going to come up here. Is 3 less than or equal to -1? No, it's not. So I'm not going to use 2x. Is 3 greater than -1? It is. So this time I'm going to use x minus 1. So I'm going to use x minus 1, which means I have 3 minus 1. So my answer is 2. So the first thing that I always do is I see what x they give me. I come over here and I look at the domains and see which one of those domains does it fit into, and that's the one that I will plug into. All right, now that we kind of got the hang of it, let's look at one more down here, make sure we can do this. Okay, so -3. So the question is, where does -3 fit in my domain? Okay, so -3, is it less than -3? No. Is -3 included here? It is. So I'm going to use 3x minus 1. So I'm going to have 3 times -3 minus 1. So my answer would be -10. Perfect. Let's look at the next one. 0. So is 0 less than -3? No. Is 0 between -3 and 2? Yes, it is. So I'm going to use this second one. 3x minus 1. So 3 times 0 minus 1. So I get -1. Right? So the last question for this is 2. So I go up here. Is 2 less than -3? No. Is 2 between and equal to -3, but less than 2? No. But it is greater than or equal to 2. So this time I'm going to use -4x. So -4 times 2 gives me -8. So piecewise functions, all we want to be able to do is evaluate with them. We first determine if the number they gave us, which of the domains does it fit into, and that's the equation that we'll plug into.